Hey guys, how you doing? Welcome back to another episode. So today we are going to solve this LeetCode problem called symmetric tree. Although this problem is marked as easy, this problem has been asked at many places including Google, Amazon and several other places. So if I just have a look at the companies, it's also Facebook, Adobe, Capital One, Bloomberg, Oracle, eBay and a lot of other companies. So this is a pretty interesting problem. The thing is, the concept of this problem is simple, but the implementation uh, has to be understood well, should be prepared beforehand, I think. And the idea is there's a interesting follow-up to this question that we're also going to solve. So this video might be a bit long, but I'll suggest you guys to hold on and go through the entire video if you want to know how we solve the entire problem in both the methods. So we'll be solving the follow-up as well. So without any further delay, so let us understand the question. So given a binary tree, check whether it's a mirror of itself, that is symmetric around its center. So we are given two examples. So let us evaluate this example. So this first tree that is given to us, this is if you can. So what is a symmetric tree basically? So if you could draw draw something like a mirror line between the from here from the root, and if the two know if the basically if you could reflect one side and the other side is same as that, so you can see that 2 is same as this 2, this 3 is same as this 3, and this 4 is same as this 4, so the value in the position has to be same. So that's why this is a symmetric tree. And for this one, if you could draw a straight line, I actually this I draw this a bit skewed. So although okay, so you see this, the root is, if there is a single node, that's always symmetric. So essentially the root is always symmetric because the middle line passes through the root. But to take the example of 2 and 2, this is symmetric. But 3 and 3, although the values are same, these are not symmetric because this 3 is the right, is the right, this is on the right side. So essentially the reflection of this one should be somewhere here. It should be something like this. It should be this 3. And the reflection of this one should be here. So it should be something like this. So that's why this is not a symmetric tree. So we have understood the concept of symmetric tree. So I think we can now go into the code. And before coding this, I want to explain like how should we approach this. So given a node, let's say we have a root. Root is always um, root is always going to be symmetric, right? But what if, so we have to create a left part and the right part. So essentially, if we have a tree, essentially if we have a tree here, uh, yeah, essentially if we have a tree here, let's say this tree if we have, so we have to check that given this is symmetric, I have to check that this part of this tree and this part of the tree are symmetric. And again, we have to iterate, we have to recurse down. We have to check for this part and this part again. So I would check that if this node is same as this node and if this node is same as this node. So let's say I'm given the left node and the right node. So how we could check that is, if left dot left has to be equals to right dot right, right, and so we have to short circuit this. So left dot right has to be equals to what, right dot left, and the left dot value has to be equals to right dot value, because if the values are not same, we would definitely not go to the left and right, the children of those. So we are going to use this steps, and we are going to code the steps, and I'll be using a subroutine that would essentially implement this logic, and I would be calling that from the main function. So let us go to the code and try to implement this, what we discussed. So first let us check the corner case. So given a root, basically if the root is empty, so if not root, essentially we just return true. Why? Because an empty node A single node and empty node is always symmetric, right? Otherwise, what we're gonna do is we create a, let's say, otherwise we are going to write a subroutine where we'll do and handle this entire thing. So self dot is mirror, and we are going to pass root dot left and root dot right. This would contain the logic for whatever we discussed just a while back. So I'll write this is mirror method, and this would take left and right, and this would return a boolean as expected, true or false. Okay, so I'm coding in Python 3, by the way. So essentially, if so what do we need to think about? If the left dot value is same as right dot value, if the left dot value is same as the right dot value, in that case I have to iterate, recurse below, right? Recurse, continue recursing. So in that case I would return self dot mirror, so it would call the same method, and in this case it would pass left dot left, right dot right, and also self dot is mirror left dot right and right dot left. Okay, if it's not, then you return false. But we need to also handle some corner cases. So what if left and right are null? So if both are null, so if left is equals to right, essentially if they are null, we return true, because essentially it's a single node in function, right? So we don't need to think about anything, we can return true. But what if either of them is if either of them is not null, so if not left or not right, in that case you return false. Got it? So that is how I think we can solve this problem. So let us try submitting this and see if this is works or not. Okay, so have we done some mistake? Yeah, this is an indentation error. Okay, typo here. Okay, should be mirror. I'm typing mirror always. Okay, I think this is good. Okay, it has to be self. How did I miss it? So yeah, I think that's enough. Yeah, so let us try submitting this, because logically this looks good, and I hope you guys understood this solution. This is the recursive solution. So let us try submitting it, and if you check, we have passed all the test cases and the memory usage is 100%. But I also want to solve the follow-up of this problem. So the follow-up says solve it both recursively and iteratively. So in interviews, technically it's very important that you solve, while you're doing LeetCode, it's very important you solve this follow-up as well, because if interviewers use this problem for your interview, they would very much, there's a high chance that they would use this follow-ups to ask you questions. So this is pretty easy to write the recursive solution, because you essentially, this is pretty much a concept, if the left dot left is right dot right, and if the left dot right is right dot left, essentially you're not going deep into how it's checking. So we are just putting in the logic and we are expecting that the recursion would handle it automatically. But what if we had to do it instead of the recursion? What if we had to do it iteratively? So an idea of doing that is, if we could go back to the whiteboard. So I would clear the board, right, and I would just check this. So let's say we have a tree, 1 2 2, let's say we have something 3 and 3 here. So if we could traverse, in a breadth first search manner, in a level wise manner, and we could take the values in each of the level, and if we could check if that list itself is symmetric or not. So in this case this would be 3 none none 3. So the list has to be symmetric, right? If the list is symmetric, how do we check a symmetric list? So this first value would be same as the last value, second value would be same as second last value. So we can like iterate half of the list and we can check for this one to be equals to this one, and then this one to be equals to this one, like that. It's very simple. It's like gonna take us linear time. Why it's gonna take linear time? Since it's big of n by 2 at each level. At the last level it would be uh, total number of nodes n by 2 by 2, so it's n by 4 essentially, so it's nearly going to be linear. Okay, but whatsoever, we have to run a BFS and we have to take the values in each of the levels. So if you want to try to implement that, we have to write BFS. So without any delay, so let us jump into the code, and I'm going to remove this code, or I can reset the code actually. Yes. So I'm going to reset the code, and what I'm going to do is I'm going to take a queue, and I'm going to use a default Python list as the queue, and I'm going to put the root initially in the queue, and I'll start iterating over the queue while the queue is present there. So I have to take how many nodes are there in one level, so I would take that first. So the number of nodes in the current level, so the length of the queue for this current level, and I'll iterate over that. I'll iterate for that many times, right? I'll iterate for that many times, and I would take the node at the head. I would do queue.pop from the front. Essentially it's a first in first out data structure, that's why I'm popping in from the first end, removing from the head of that and appending at the tail of that. So I'll see how we can append it, and if the node is there, so if it's not null basically, so you just do an append of node dot left. So even if it's null, we are going to append it, but the node has to be not null. Essentially if it's a leaf node, we are not going to run into an infinite loop, so that's why we are appending if it's not null. So q dot append node dot right. So the dot right dot left, that can be null, okay, but the node is not null. So what I mean is, this logic is the our logic would go till this node also. Okay, just let me change the color. So our logic would go till this node also, because the left is not null, the right is null. So we are essentially going to add this element into our queue, and also add this one and this one into our queue. But next time when we pop this, and if when we go to the next level, all if this is none, we are not going to add the left and right of that. So if that would have happened, if we would have run into an infinite loop. So we don't want to do that. We want to go up till the last level and an extra level, just to handle it much more simply. So this is like the stopping condition. If node is there, only then continue. Okay, so we need the values, since we are going to compare the values. So I'll take a list called vals, and it's going to be empty. So these are the values of current level. Okay, so the vals dot append would be taking the node dot value. So all the values of the current level, they are going to get appended into this list. Okay, what if there is no node? I'm just going to append vals dot append none, because there's no node actually for that level. This is needed because let's say we run into a condition where this is not same and this was not there, rather something like this was there. Okay, so in that case we want to append a none here. So for this level we don't want only 3 and 3, so it will become a symmetric level. We don't want it to be 3 and 3, we want it to be none, 3, none and 3. Okay, something like this, so that this is not symmetric. So we also want to count the null nodes basically. So that's why if it's not there, we want to append null for the values, and that is all. So now we have to check if that level is symmetric or not. So it's very simple. So we are just going to run over that that we created for I in range length of vals. Okay, and we would not go over completely, because we would go over half, because we want to check the opposite end, so this can be done without going over the entire loop. So if values of I is essentially not equals to values of so in Python you have this method of -1 to be the last element, -2 to be the second last element. So I'm going to use that logic. If you want to, you can use another logic. You can use something like take this n as the length of the vals, and okay, let's do that. It would be simple and much more readable, I guess, for everyone. So I would just do this n minus I. Okay, so vals minus n minus I, so this is 0. This would be n minus I minus 1 should also be there. If these are not same, okay, if these are not the same, then we return false. Otherwise we are going to return a true. Okay. Okay, the returning of true should happen outside this, so I need to remove the indentation from here. And once I'm done with this level, I need to reset the vals array. I need to clear it up for the next level. So that's why I would clear this up value array and I would reset it to empty list. So I think that's it. So let us try running this code, and this is the iterative method. We are able to run it. So let's try submitting this and let's see how it works. Great. So okay, actually this is much more faster as well. This is 93% on Python and 100% memory. So that's even great. So that's it. That was the solution for this problem called symmetric tree, and as you guys saw, this is the solution. So this is a very important problem, and I hope you guys understood. You guys learned something out of this video. So do like the video and subscribe it, share it with those people who need this, who need to know this channel. Basically, this helps me a lot. That's it. That's it for today's video. Happy interviewing. Happy LeetCoding.